Hi, this is Sandhya. Today I am gonna tell you about DTFT. It is expanded as discrete time Fourier transform. In simple, it is applicable only for discrete signal, that is x of n. X of n, if it goes for DTFT, equal to x of omega. The formula for DTFT is, just remember this, x of omega is equal to summation of minus infinity to infinity x of n e power minus j omega n. Just remember this, whenever the discrete comes, the summation must be in the formula. In simple, discrete time signal can be represented in frequency domain using DTFT. Next we move for DTFT existence. Under this, 3 points you have to remember. Firstly, Fourier transform of discrete time sequence x of n exists only if x of n is absolutely summable. That is, summation of n is equal to minus infinity to infinity modulus of x of n less than infinity. Next, DTFT can be used to analyze the system whose transfer function has poles inside the circle. Finally, it is not applicable for exponentially growing sequence because they are not summable. DTFT can be used to find magnitude and phase. In simple, we have to find x of omega. Here moves for a problems. The first one will be find DTFT. Here one function is given. For x of n is equal to u of n. We know x of n equal to u of n. We know the value will be 1 and 0. 1 for n greater than or equal to 0 and 0 for n less than 0. Next we move for formula. We know f of x of n equal to x of omega. We have to find equal to summation of n is equal to minus infinity to infinity x of n e power j omega n. We know this formula. So here we have to substitute. N is equal to minus infinity to infinity. X of n is u of n and e power minus j omega n. Substitute the values. N is equal to 0 to infinity. That time u of n is equal to 1 e power minus j omega n equal to f of u of n equal to 1 divided by 1 minus e power minus j omega. This is the solution for that problem. Next, find DTFT for here numerical series x of n is equal to 1, 3, minus 2, 5. We know the formula f of x of n equal to x of omega equal to summation of n is equal to minus infinity to infinity x of n e power minus j omega n. Here substitute the value, that is x of 0 e power j omega 0, that is n is equal to 0 first. Next x of 1, same n value is equal to 1, so e power minus j omega for n value is equal to 1. Again x of 2 e power minus j omega 2 plus x of 3 e power minus j omega 3. From the question we have to find the values of x of 0 to x of 3. Looking for the question, x of 0 is equal to 1, x of 1 equal to 3, x of 2 equal to minus 2, x of 3 equal to 5. Next, we have to substitute all these values in the last step. X of 0 e power minus j omega 0 plus x of 1 e power minus j omega 1 plus x of 2 e power minus j omega 2 plus x of 3 e power minus j omega 3. We know x of 0 value is equal to 1 and e power 0 value 1 plus x of 1 value 3 and e power minus j omega plus x of 2 value minus 2 e power minus j omega 2 plus finally x of 3 value 5 e power minus 3 j omega. So the answer is 1 plus 3 e power minus j omega minus 2 e power minus 2 j omega plus 5 e power minus 3 j omega. In this session, I discussed about what is DTFT, DTFT existence, DTFT uses. Finally, on problems, looking for the problems, I used to solve two kinds of problems. One is giving only signal input and next one is giving numerical input. In exam point of view, simply x of n is given in the question. We have to find x of omega. For that, we know x of omega is equal to summation of n is equal to minus infinity to infinity x of n e power minus j omega n. X of n is given in the question. If it is a signal input, you know easily the x of n, or if it is a numerical value, first find how many numbers. If 5 number exists, find from x of 0 to x of 4. If 3 number exists, find x of 0 to x of 2 and substitute the value given in the question. Finally, you will get the answer x of omega. So this is all about DTFT.